Hi everyone, my name is Anvita Bansal and we are back with another lecture based on strings. So the problem that we are going to discuss today will be longest common prefix in an array. So what you are given an array of strings in this problem and you need to find the longest prefix which is common in all of these strings in the given array, right? So let's understand this problem. Let's have a look. Okay, let me just check if you guys are able to see my screen. Give me a second. I think yes you are. That's okay. So let's understand this problem. You will be given an array like this. Let me write the array here. Let's see. Geeks. Okay, so this is the given array. Let's understand with the help of this example. Fine. Now if I talk about this array of strings, it has certain strings. What is prefix? We already discussed in the previous problem. Prefix is any substring which needs to start at index 0. Now we need to find such a prefix which is common in all the strings. So what can we do to solve this problem? Okay, let me just okay, so let's move to the discussion. What can we do is that for each string you can check two strings at a time. Okay, you check for two strings at a time. Let's say this is S1, this is S2. Okay, and for each string what you're gonna do is, let me by that time also check if you guys have any doubts, you can write in the chat. Okay, fine. What you can do is, for two strings you will check if what is the common length of, or what is the common prefix in both the strings. If I am giving you geeks for geeks as one string, okay, just think of a function which is comparing only two strings, and that task is very easy for you, right? What is that task? You iterate over the each character in both the strings one by one. If they both are same, you move ahead, you move your pointer to the next character simultaneously in both the strings. You found them equal again, you move your pointer to the next character in both the strings, you found them equal again. Here you will find them equal. So in what cases will you come out of this loop where you are comparing each character? One possibility is that character does not match, right? That is the case, you will come out of the loop. And other case can be one of the string is completed. That means one of the strings length is now there is no more character to iterate. That is length, or that iteration, or let me write it like this. Your iterator becomes equal to the length of one of the strings. I becomes equal to length of one of the strings. So the one which will be shorter string will be iterated, means its length would have been iterated first, so we'll have to come out of the loop. So by that time, whatever prefix you must have got, let's say we stored it in res kind of a string. So what is the longest prefix we got for these two strings? Was geeks. Okay, so we know if I had this string and this string, then the longest prefix would be geeks. Now use this res. So you got res as one of their prefix. Now use this res to compare with the next string, that will be S3. Now res will be compared with geek. So this was res. Now compare geeks with res is compared with geek. So what was res now? It was geeks. Okay. Now you all again implement, your function will be written, and now that function will be checking for these two strings. Now again you character by character you compare until unless you come out of the, you only come out of the loop if you have iterated over the entire string, one of the two strings, or the case is that the character does not match. So till here, till here, till here, we'll find all the characters to be matching. So our rest will become geek in this case, correct? Now in this case it was geeks. Now when I compared res with S3, basically, now when I compared res with S3, what res result I got on comparison geek as my prefix, longest prefix. So this was S3 and this was your result. So the resultant longest prefix I got was geek. Okay, now compare this geek with the next string in your given array, which is geezer, let's say, whatever you say this word. So now what is the longest prefix you get on comparing geek with geezer? So let's see. Now you have geek, other word is geezer. So again you character by character you check equal, obviously one by one. Now this is lying in the first case which is the character at this position does not match with the character in the second string at the same position. So this is the case, you will come out of the loop. Would you like to, let's say it was geek let's say, in this case also you found a mismatch, will you still keep iterating over the string? No. As soon as you find one of these two conditions, you immediately come out of the loop and your result will be left with whatever you added into result, which was GEE so far. So the longest prefix for geek and S4 will be GEE. And I think this is the final result that you should be returning because there are no more strings to compare. So I hope you understood, you got the gist of this approach. So this is one way in which we can do. We'll be solving using this method with certain modifications. I'll tell you what. The modification will be, we are checking in the second condition, we are making a check, one of whichever string is smaller, and you are done with iterating over that entire string, you come out of the loop, you break it. Rather than that, what I am going to do is I am going to iterate all together for the smaller length of the string only, the string with the smaller length, let's say that is capital N. So I am going to do the iteration for that part only. If I had to find the prefix will be found within this range of indexes, otherwise it will not be found. So I'll make that comparison beforehand. That's the only modification I'll be doing in this part. So I think let's move to the solution. It's very easy. There's another approach which you can solve. Another approach says what you can do is you sort this array of strings. So on sorting it, it will look something like this. Let me write it. How is it going to look like? So what do you have is GEE, I think. Let me check. First it will be geek, then it will be geeks, then it will be geezer, and then geeks, geezer, not geek, then it should be GEEKS, then it will be geeks, for geeks, and then you must have geezer as per me. So what you can do, you can sort this array of strings, whatever array you have. How sorting is going to help you, that in this case you are going ahead and iterating over this sorted array. I am writing here sorted array of strings. The modification in approach 1 can be, you just sort this array, and then for each index, for particular index, you go ahead and check in each of the strings if that character is present. So it just mind this thing that we are not sorting the string, but we are sorting this array of strings. For example, if your array was like this, A, B, AC. So if suppose you are given an array like this, let me write it here. Wait. Let me take a smaller example. Suppose you have an array of strings. On sorting, it looks like this. Let's say this is a sorted version of that case that I am taking. Suppose it looks something like this. A, B, let's say, and this is A, C, C. For example, this is what we have in the sorted array. So these were the strings that I was given, and now I have sorted this array. So let's say it is going to look like this. Fine. Now what I'm going to do, let's say I am doing an iteration starting from I equal to 0, and these strings need not to be of same length. Okay, let it be Z, let it be B. Okay, these need not to be of same length. I've just taken an example. Let it be a. So what you will do for I equal to 0, check for I 0 in all the strings. What will you get? You will get a in all the strings. This is a double c z, or let it be a c z. Fine. So I get for I equal to 0, this is also a, this is also a, and this is also a. So I will append a to my result. Fine. Now increment the count of I, it will become 1. Check for the next index, be a. So as it is a match in these two strings, but it is not a match in the third string. As and when I find that a character is not matching in any of the strings with the other strings, that means I should not move ahead in my loop, just return result whatever you found so far. For example, let's say this was also a. You increment the count of I, it becomes 2. Now what is the scenario? The scenario is, see what will happen in this case, the one with, now this array has reached index out of, will have reached index out of bounds. So that is the second condition according to what we discussed. So you will come out of the loop, again return what was present with the rest. Okay, so I think not for this test case, not, I hope you got this problem also. There is one more approach 3. If you are well versed with tries, okay, if you know what tries are, then this question can be solved using tries also. For that, the prerequisite is you understand what tries are. Okay, so what can I do? There's a root node, right? And for each node I am going to take some int word count. Let it be the count of the string that I am taking, or maybe I can take a string itself. I can take a string also. It's up to your choice. You can take the string itself, string result that is giving you the string, or you take the count. I think it will be better option to take the count in this class try. This is the class try that I am trying to show you. I'm not going to go ahead and do it completely. We are not going to use this method to solve our problem, but I am giving you the idea that it can be done in this way if you know what tries are. Then you can have int count. That count is telling me the length of prefix so far. And then you can have child node, this is node, child, okay, this is parent. Do it yourself, you can understand it. Fine. So at every step what I'm going to do is I'll be iterating over this. These words. I have G. What is the, let's take a smaller one. Let's say I have AABB and AZ. So answer should be AAZ. So answer should be AA. Okay. So what will I do? I'll add first character of first word. I'll add A, and this time it need not to be sorted. Just don't confuse. I'm just taking the second example because it's smaller, but you don't have to be confused. Okay, so in your try you add A, then you go to the next character of A, which is A again. So you got one child. What is the count for this one? 1. Count for this next one is also. See, this approach you'll only understand if you know what are tries. Then you take one more A, which is, and the count of this is also 1. This is the longest prefix it has so far. Okay, now for each word in itself is taken as a parent node. Okay, then for, if I consider this as my parent node, what is the length of longest prefix? 1 only. Okay, because it is single element in itself, character. Okay, coming to the next character, which is next string's first character, which is A. First of all, tell me one thing. This A is equal to this A. Okay, fine, it is equal to. Now what is its child? Its child is equal to this child. So can I increase the word count? Yes, I can increase the word count. Okay, now the next character of this word is B. Can I make it as parent of this A? Yes, and make its count as 1, because this is the first time I found it in this string, and its count will be 1. The prefix count for it will be 1, longest prefix. Now this B has another character which I will add as its child node, so its word counter will also be 1. Now you move to the next word's first letter, first character, which is A, and you start from the root node. You make a check with the already existing node. So already existing node says that I have a character A whose count is 2, which matches with my current character. So I will increase its count and move to its child node. What is the next character of this A? That is also A. And what was the child of this A? That was also A. Both of them match, so I simply increment the count of this A, right? So this count only tells me the length of longest prefix so far. Now what is the next character of this A? That is Z. So what is the this child of this A? It is B. Is it equal to Z? No, it is not equal to Z. But it has to be taken as one of the child because it is coming after A. So I will create another child node Z with count 1, right? So you are getting this point. The counts are telling me, these counts are telling me what is the length of longest prefix so far. Also means in which all strings it was found, not length of longest common prefix. Let me correct this thing. The count is telling me in how many words was this character found. So when I do not have any more characters to iterate over and add to my try node. Okay, now what I get from the count is that I will, when I backtrack, I will see there are no more. Do I have any more characters to add for Z? No. I go to the previous node for A. Do I have any more characters to add? No, I don't. Then I go at this and so on and so forth. So from there I'll get the information that the largest word count was 3 for this A. The largest word count was 3 for this A. So it tells me, and this 3 is equal to the number of words, correct? So when I know this, from this information I can deduce that parent node A and its immediate child node A, both of them had this word count of A. First of all, I got this information from here. It was not equal to the number of words. I backtracked. There are no more calls to make. When I come at this position, I find it to be 3. Now I backtrack to its parent node. It was also 3. So from here I get that these are the 2 characters which will form the longest common prefix, right? So this was just to give you an understanding, not that we are going to solve using this method, but I really want you to go through this approach as well and try to solve it. Okay, so let's move to the problem now and solve it using the first approach that we discussed. So let me just write it. Give me a second. Okay, so what I discussed was, let me show you back again. So we are going to solve using this approach 1, correct? Cool. Let's move to the problem. Let me take a string current. You can take current or current. Let's take current is equal to ARR of 0, right? Now your current will be updated as the longest prefix so far when you will check with another function this string 1 which will be current and another string which will be your ARR of I. So let me also take a loop for I and T. Since you have already taken the 0th string in current, let's start from index 1 less than or equal to n minus 1 plus plus. Every time you are adding this, you are updating your current with the longest prefix, right? It is getting updated and that prefix goes into this function and the next string of the array goes into this function for the comparison. I will write this function. Okay, fine. When you come out of this loop, you check if your current dot length is equal to 0. That means nothing got added. So what will happen is it will return you an empty string. If you want to return current, in the otherwise case you return res. But you need to put a check. Sorry, you will be returning current, which will be the longest prefix. But what will happen with this approach, you will get an empty string if there is no common prefix. But your question says if there is no common prefix, then you return -1. So let's take one string result equal to, I want it as character, so I return result, otherwise you return current. So this is just one check. Now my task is nothing but to make this function public string, what is it, check for prefix. Okay, so you have string A, you have another string B, I am going to check which is the smallest string out of 2. So int capital N, let's take math dot min of, one second, math dot min of a dot length and b dot length. So I'll do the iteration for this range of indices only. So let me take int I equal to 0 while I is less than capital N, correct? You check for each character. If a dot char at I is not equal to b dot char at I, correct? You should come out of the loop. Simply break out of the loop, correct? In the otherwise case, in the else case, first of all, you add into your result, you update your result. Let's say string res initially was an empty string. Okay, so res plus equal to a dot char at I, and then you increment the count of I. That's all, fine. And finally, when you are out of this loop, you will be returning this result. Okay, so let's try to run it. That is all about this problem. I hope you understood this approach. This is a very simple approach. Nothing. The idea only was to compare two strings at a time. Okay, that's what we did. Fine. So if I come at its time complexity, for I am using a loop which is iterating over the length of this array. So big O of n, and for each of that I am calling this function. So what is the time complexity of this function? So this function is iterating over the length of the shortest string. So the time complexity will become length of your array, let's say n, multiplied by length of the smaller string. Okay, so that is your time complexity. So at any point in time, the smallest one will be the maximum that this while loop will ever go. Okay, so let's say I started with geeks for geeks and geeks. So what is the smaller of these two? This one, capital, this one, geeks. Then I iterate over these two strings, smaller of these two, geek. So for every index I am taking the smaller index of the two. So I think that is all about this problem. If you have any doubts, you can ask me in the chat. Let me just open up, or we will wrap it up. So if you have no doubts, let's wrap it up, everyone. See you all in the next lecture on strings. Thank you and bye bye.